this tutorial, we will create a 3D pixel line extrusion effect in Max. So before we start, maybe we should discuss what we're trying to achieve here. The basic idea is that for every pixel of a given input video, we will draw a 3D line downwards. We will position this line in 3D space and we will also control the length of the line. This kind of looks like pixel sorting, but in a 3D environment, which is pretty nice. This tutorial consists of 3 parts. In the first one, we will use the input video to create a grid of pixels, which will be like the starting points of our lines. In the second part, we will draw the actual 3D lines, and in the third one, we will adapt the color. I will start with a jit.world object, jit.p window, and here I have a nice input video. So the first thing I want to do is I want to downsample this texture. Maybe we can take a quick look at our input video. So we have this drone shot of this mountain range. But this is in full HD, so 1920 by 1080. So I guess this will be too many particles. So to downsample this, I will create a jit.gl texture object. Specify its dimensions. Let's do 480 by 270, which is still the same aspect ratio, but downsample, then adapt 0. Oh, didn't mean to do that. Adapt 0, so the output doesn't change. So now, yeah, still the same video, but lower resolution. Then what I want to do is I want to turn this into a matrix because we're going to create points in 3D space using the jit.gl.mesh object. So in order to control these points, we need a matrix. So let's create this one for planes. Also float 32. Then of course we need the same resolution, and also just to be sure, say adapt 0. You could plug this in here directly, but it's better practice to use this, what's it called, jit.gl async read, so we can read back from this texture and turn it into a matrix. Then let's have a quick look. Okay, looks good. Now we can create this pixel grid. To do this, I will start with a jit.gl.mesh object, but I will draw points first. So jit.gl.mesh at draw mode points. Maybe we give them the color white, and then we can say point size is 10. Did I make any? Okay, no, this was an earlier mistake. Okay, then I will create a jit.gen codebox. So what I want to do now is for each of the input pixels, I want to create a particle or a point and then position them in 3D space. To do this, we can just use normalized coordinates. So I can say something like I would just call this UV equals normalized coordinates of X and 1 minus normalized coordinates of Y. And then I send this to our output. And then we can have a look at it. So why is it doing this? So we're expecting just normal UV coordinates here. What is happening when we're doing it like that? Okay, I see. I think because of the way this texture is turned into a matrix, we have to unpack our planes first. So we need to say jit.unpack one output, then I want one offset, and jump 3 because I want 3 planes in the end. Okay, now it's working. So what we're doing is we're specifying that we need one output. Offset means that we want to start at the second plane, because here the first plane would be the alpha channel. So we want to start at the second plane and we want to have an output of 3 planes. This is what that means. And now it's working. Okay, and you might be wondering why I'm writing it like this. So normalized coordinates of X and 1 minus the normalized coordinates of Y. Because if you're looking at it now, on the X-axis, we're going from 0 to 1, and on the Y-axis, we're also going from 0 to 1. But in this case, the 0 is on top. But when we're working with our 3D coordinates, the 0 should be at the bottom. So I'm using 1 minus this. So this is what we actually want. Then we can already plug this in here. We still have this background image. Maybe I can get rid of this. Okay, erase color is white. So let's turn this to black so we can see where our actual points are. Okay, now we can see that our points are in this corner. So in order to position them across the whole screen, I guess there are more systematic and better ways to do this, but I will just use a parameter and call it scale to scale what's coming out of here. So to make this explicit, first of all, I want this to go from -1 to 1. So I can say UV equals UV times 2 minus 1, because now it's going from 0 to 1. So if I'm multiplying it by 2, it goes from 0 to 2. And if I'm subtracting 1, it goes from -1 to 1. So now we have this one. Then, okay, before I'm scaling it, I will use a camera object. Because if I introduce the camera later, then I'd have to scale it all over again. Position 0, 0, 5. Okay. Now we can say UV times equals scale. Oh, but then I'm also scaling. I guess I could just say something like this. So we're only scaling X and Y, and we're leaving the Z-axis at 0. And then we will scale this so that it fits our screen as best as possible. And maybe I can also change the point size to something smaller so we can see the individual points. Yeah, something like that. Okay. Yeah, so as you can see, this is not an exact science. I'm just trying to get this across the whole screen. Okay, I'm satisfied with these values, so then I can hard code them in here. Okay, now they're staying. Okay, so now we have our points across the screen. What we already could do is also send this matrix that's coming out of here as our color input here. So now we can see that each point gets assigned the right color for its position. Okay, then we can move on to the second part where we draw the actual 3D lines. So now for every pixel, we kind of have one point at the right position with the right color. But now for each pixel, I want to draw a line and drag it or extrude it downwards. So to create our lines, we must say draw mode lines, obviously. Then what also, yeah, line width, let's do 2 for now. What also looks nice is if we say blend enable and then using, I don't know, color blend, then we should also change the alpha. Okay. So I'm not sure if you're able to see this now, but yeah, I will just move on and then we can look at this later. Okay, so what I want to do now is I want to pick like the starting position. So the starting position will just be like the incoming position, and then an end position will be the starting position plus a y offset, so an offset on the y-axis. And the way these lines work is that, so I don't know, imagine we have these 8 pixels that are on the x-axis. Then the way that this object draws the lines is it would draw a line from 0 to 1. Then it would draw a line from 2 to 3, 4 to 5, 6 to 7, and so on. So the problem now is that if we draw it like that, I'm not sure if you can see what's happening. It's just drawing the lines downwards. So we need a way to first set a starting position, then an end position, and then to interleave both of those positions. And to do this, we can use this object jit.multiplex. So this will essentially do this. So if we have If we have two matrices, A and B, then it will draw a line from A0 to B0, A1 to B1, A2 to B2. And in that way, it's easier to control what we're doing. So I'm going to show you quickly how I will approach this. So we'll use another, jit.gen codebox object. Just put this in here. And then I'll say something like line start equals 0 and line end equals 1. And then output 1 will be line start. Output 2 will be line end. And then I can plug this multiplex in between. Okay, maybe to make this a bit more explicit, let's say 0, 0, 0, and here we can say 0, 1, 0. So now you can see that we're, for our first point, so A0 will be line start, B0 will be line end. And then, of course, if we scale this up, if each input point, if each input starting point gets a different output ending point, we will have all of the lines that we need. I'll try to make a bit more space up here. I mean, we could also maybe put this one here. Okay, then yeah, let's create our starting points and our end points. So the first input, I will just call this one position. This is input 1. Then I want to change the length of the lines depending on the input color. So the brighter the input color, the longer the lines. So I also need a color input. This will be input 2. And then we can say, okay, our X position is the X position of our starting point. Then our Z position is the Z position of our starting point. Because X and Z will not change because we just want straight lines. The only thing that we want to change for the ending position is the Y position, because it will be higher or lower on the screen. So what we already can do is say this is X, this is X, this is Z, this is Z. And then we can do something like Y start is position.y, and then Y, let's call it Y end, equals position.y minus, we can just use the brightness of the color. So we can say RGB to HSL. of our color input and then take the Z value. What we can also do is create a parameter, call this one length. So we can control the length of the lines from the outside and then just multiply this by our length. So what we're essentially doing is, yeah, X and Y is the same as the input, and then, no, sorry, X and Z is the same as the input. And then for our Y starting position, we're taking the input position, and then the ending position is of course the input position plus some offset that goes downwards. So then if I say Y start, Y end, plug this in here, I don't get anything. And why is that? Because first I need the color input. So coming from, or maybe I can do it like this so it looks a bit nicer. So here is our color input that's coming from up here. What am I doing? Okay, position is coming in here. The color is coming in here. Yeah, and if I shorten the length, you can already see that we have a line length that is depending on the color that's coming in. Maybe, yeah, we can do a third output of this matrix and send it directly down there so we can see what is happening in terms of colors. So here we have the color input. Yeah, so this is not quite right because of course we're doubling what's coming in here. So in order to get the color here right, we need to create another matrix and essentially upsample this one. So we need double the number of pixels on the x-axis, which would be 960, at depth 0, and then we also need to interpolate. So yeah, because of this multiplexing here, oh, I also quite like these glitchy artifacts. But yeah, because of this multiplexing here, we're essentially doubling what's coming in here. So we also have to double it on the color side of things. Maybe we could change the line width a bit. Yeah, now you can see that's kind of going into the right direction. But we're still missing something. What I also want to do is create some kind of a noise offset, because now they're very orderly, so they all have kind of the same distance to each other. So let's mix this up a little and create jit.noise object 3 float 32. And then also, because we have, or actually do we? No, it can just be this resolution. Then let's say, let's just call this one offset equals in 2, then this can stay input 3. Just that it's not that cluttered up here. So yeah, the color is now input 3, our offset is input 2, and then we also can say load bang. And now we can apply this offset. So maybe first we can create a parameter, call this one offset amount, and do something small so it doesn't go crazy. And then of course, there are many different possibilities where to apply this. I will apply it to, okay, I will first create a new variable, call this noise offset, and this equals our input offset multiplied by the offset amount. And then we can add this to our X position. And also to our Z position. Yeah, now you can see it's not that orderly anymore, but it's noisier, which looks kind of nice. Then what I also forgot is we need to add depth. So we can say param depth. So this will just tell us how, like this will be the distance along the Z-axis. So let's say, and I think I'll put this up here because I guess it's more important. Okay, and then the depth, we can apply this to the Z-axis. So this is depth plus the position, and then when we change this one here, but I think they're just moving all at the same time. In order to see if we really have this depth applied, we can rotate this. Okay, no. So there's no real depth going on. I guess we could also make the depth dependent on the color that's coming in. Because now this value is the same for every line. I mean, position.z, we don't need it because it will just be 0. So we can put this in here, and now you can see that depending on the brightness, we have some real depth going on. Okay. That's nice. Now we can change the length. So this is almost the effect we want. But as you can see, I will get rid of this here. I put this whole thing here so we can make this one bigger. As you can see, it kind of looks like pixel sorting, but then again, it doesn't, because the starting point of each line has the same color as the end point of each line. So I want to create another jit.gen codebox that changes this. So to do this, we need one here that changes the color. So I guess that's then the third part of the tutorial. So in order to change the color, we also have to specify here that we want smooth shading, which means that there will be an interpolation between the starting point, or the smooth shading in this context means that we're interpolating between the color of the starting point of the line and the color of the end point of the line. So we will have like a nice gradient. Okay, in order to do this, yeah, let's just, as we did here, define a color starting point and a color end point. So a color starting point is just our input color. Color end is, I mean, you could essentially change this however you want. I will just make it darker for now. So this is our input times 0.25. And then I think if we're getting rid of this, oh, nice glitches. Okay, output 1, it's just color start. And output 2 is color end. And then of course we have to multiplex this again. Yeah. Then we also don't need this one anymore because due to the multiplexing, we're getting essentially these dimensions. Okay, now you can see that the pixels are, or our stripes are getting darker the further down. Yeah. So here we can control the depth. Here we can control the length. And as you can see, the length is on the one hand dependent on this length parameter, and on the other hand on the brightness of the pixels. So the brighter the pixels, the longer they are, and also the brighter the pixels, I think brighter pixels are closer now. So depth plus the brightness. So let's see. Yeah, the brighter pixels are closer now. And then you can get this kind of fake 3D pixel sorting effect. I'll just make a bit more space here. Make this one bigger. Yeah, this could also be done with live video. But yeah, another thing that we could do is use this slide object. Slide down, I don't know, 15, slide up 25, because now you can see it's quite noisy when we're changing the positions. So using this slide object will change the positions gradually. So there will be kind of a filter. So now it looks a bit nicer. Also, if you're changing the length, it's a bit smoother. Yeah, pretty nice pixel sorting looking effect. Okay, This was essentially what I wanted to show you. I hope you found this useful. Thank you for watching.